Welcome back to part 2 of the base building series. In this part, we're going to be going over setting up the snapping and making the buildings snap to each other. Let's get straight into it. The first thing we need to do to get kind of the basic of the logic running is we need to add the input for snapping, because we made it here, but we didn't attach it to our IMC. So we're going to add it to our input mapping context here. So click the plus, select the snap right here at the bottom, and we'll set it to shift. So if we hold shift, we're going to be able to snap from one building to the other. So let's do save, and for now, that's all we're going to do there. What we're going to do now is we're going to make it so that we can actually see them and create them. Because right now, even if we add anything, we can't actually see it. We can't use it yet. So the first thing we need to do is we need to make them visible. So to make them visible, we're going to use our SMC Snap here to act as kind of the visual representation of our snapping points, because in reality they don't technically exist. They're just going to be a transform position that's relative to our static mesh. So to get them to work, what we're going to do is we want to make them visible. To make them visible, we're going to get our static mesh and set it to our, I believe it's chamfer cube. So that's just the basic chamfer cube from Unreal Engine. We're going to compile, and we don't want to use the blue because the blue doesn't really ring as a attach point, at least not to me. So we're going to make a new material for that, or we're going to make a new material instance, and we're going to use the blue here to make a new instance for it. So we're going to look in here for our material, and we're going to look for a material instance, and we're going to say mi solid underscore, and we're going to say yellow, and we're going to have another one later that's going to be red, but that's going to be in the next part. For now, we'll leave that on the side. So open this up. And by default, it's going to be empty because we don't have a parent associated with it. So to associate the parent, we're looking for our solid. And that is going to be solid right here, M. And now we have our properties that we're looking for. So we only need to change our surface color. And we're going to change this to a nice yellow. So drag the red and the green. And there we go. So we have a nice yellow. Now it looks a bit imposing here, but it's not actually that bad because they're going to be quite small. Now, to make sure that they stay small, because if we change this here, it won't actually stick. It will actually reset back to 1 every time we create it. So on begin play, we're just going to say set scale 3D and set world scale 3D to, I believe, 0.3 is good, 0.3 and 0.3. Now, by default, we also want to make sure that these do not actually get hit by any line traces, because as I just said, they're only the visual representation. So we want to select our class defaults, and that will open up this details here. And we want to disable generate overlap because we don't care. And we want to say no collisions here. And we can also just, I believe it has shadows, and I don't think we need those either, if I'm not wrong. Yeah, cast shadow, disable that. We don't need it. We don't want it to be kind of interacting. It's supposed to be fake. It doesn't actually exist. So that will do it here. I don't think we need anything else. And just to show you what it looks like, we're going to add in our components an SMC Snap, and that's what it will look like. Oh, wait, I forgot to do something. I forgot to actually change its color. So back in our blueprints, SMC, we want to change our solid blue to our solid yellow. Compile. And now it is yellow. Now, right now it's 1, 1, 1, but it's once we play, it'd be 0.3, 0.3, 0.3. So it's not actually that big. So if we just put this here, so we can see it relative to our cube here. So if we press 1, that's pretty much the size we are dealing with here. So it's not that big. So one thing that we're going to do, because it's annoying me, is we're actually going to remove our debug here. It's not necessary anymore. So we don't need our SMC anymore, and we're going to be adding them at runtime. Now, I believe, oh, I deleted the wrong thing. We want to delete our SMC, not our static mesh. There we go. The next step is, before we do any of the logic of attaching stuff, we need to make the logic to create the attach points. So that's the first thing we're going to be doing. So to do that, we're going to get our A builds and place it right here. And inside of the construct script, we're going to do a bit of work first. So we're going to go through something first, even though we don't use it yet. We're going to do that and we'll just leave the second part on the side for now. We're going to open our SnapPoint structure here. And in the SnapPoint structure, we want a transform. And this is going to be our SnapPoint. And the second one is going to be filter. And the filter is going to be DA blueprint as a soft object reference. And it's going to be an array. And I won't be discussing this here because it's going to be the third part. So we're just going to be using this for now. And normally what I would have liked to do is we would just add our snap point here as well, our structure that we just made. But the thing is, what we want is we specifically want to be able to modify it in editor in the actual viewport, but you can't do that with a structure. It has to be a transform itself. So we're just going to kind of have to transfer information across, which is a bit annoying, but it's by far the easiest way to do it, at least from my opinion. So we're going to make a new variable called SnapPoints, and this is going to be an array of type transform. Now, so that we can actually see it in the world, we have our show 3D widget here, and to use it, we need to do instance editable show 3D widget, and just like that, we now have right here our actor. If we click on snap points on the right here, we can actually add an element that we can move around, rotate, and scale. And this will be represented in that value right here. So it's a lot easier to use instead of typing this because we actually get a visual representation of what we are doing. So what we need to do next is in our construct script, we need to transfer the information from this to our structure, because the structure is going to be the one that contains information and transfers it to the data asset right here. So right here, we're going to have snap point filter, we'll call it. It's not actually going to be used as a filter yet, but that's what we're going to be using it for. So st snap point, and we still want to keep it as an array. We don't need it to be instance editable, I believe. No, we don't need it to be, actually, sorry, we do need it to be instance editable, but we're not going to be using it as instance editable just yet. So as I mentioned previously, we need to make a distinction between a object that is already been placed or an object that hasn't already been placed. So to do that distinction, we're going to use the instigator. So is valid right here, it's going to check that. So we're going to get our instigator. And if the instigator exists, that means that we are placing this at runtime. That means that we just pressed 1 and we're trying to place a 4. And in that case, we don't want to do this logic because we only want to do this logic when we are creating our actor here. So press Control and get our snap point. Press 4 for each loop. But not press 4, but just for each loop. And what we're going to do is we are going to go through this and we're going to say from our snap point filter, set array element. And the element we want, the index will go right into the index. We'll split the item by right-clicking split, and we'll put size to fit because we want to make sure that if there's one extra here, it creates one extra here. For the transform, we just connect the transform, no issue there. For the item filter, we need to get the item filter because we don't want to change it based on anything else. We don't want to reset it. We just want to use what's already there. So get copy from the array index, split this again, and plug the filter in to it like that. Now, the final thing we need to do is we need to make sure that if we have too many of these, that we remove them. So we're going to copy our snap filter here and our snap points, and we're going to say length for both of them. And what we're looking to find, sorry, not that aligned. What we're looking to check for is while, so get a while loop from our completed here, while our length here, sorry, our snap point length is inferior to our filter points, because this one is kind of deciding how many of these exist. If there's more of these, we want to delete them. So what we'll do is we will just say snap point filter, remove index 0. And it doesn't really matter if it's index 0 or the last index, because the next frame this will be updated and it will fix the fact that the 0 has been removed. Okay, so now with this, if we go and test this again, right now if I add a snap point here, a normal snap point that we can move, it will also make a duplicate right here. And if we move our snap point here in the real world, in the viewport, then it will change the value of the snap point in the filter as well. And that's exactly what we want. So we'll just delete that for now. And the next step is we need to tell it how to use this information and store it in our data asset, because right now we don't have that. Now, to do that, we first need to update our data asset to take in this information. So right here, we're going to go and say our data assets, get the data asset blueprint, and we're going to make a structure, or get our structure, sorry, and save it here. So this is SnapPoints. Just call it SnapPoints. We don't need the rest. st snap point, and right click here to turn it into an array, compile and save. We don't need this anymore, and close it. And now we could do this in the construction script, but if we do it in the construct script, it will run more often than we actually want it to. For instance, right there, just by saving, it actually ran itself, and we don't want that, because if we save it here, that means if, let's say, you change your data asset, then it will copy all the information you just did to that new data asset, but you don't specifically want that. So what we'll do is I'll make two functions, one for loading, one for unload, one for saving, and we'll make them call in editor so that we can actually click a button to say, well, load this one that we just put in, or save it to this one we just selected, or to one we've just been working on. So that's why this is exposed here. So a new function here, which we'll call load data asset, and another one we will call save data asset. And so make sure for both of these you click call in editor, compile for that. And normally, if you've done everything right, they both appear in our defaults here: load data asset, save data assets. The first thing we need to do, just like with our event begin play here, we need to make sure that that data asset exists. So we're going to do a branch here as well. This time we don't need to destroy it because it's in editor, so it shouldn't be necessary. So on load, because we want to get the information, it's the same obviously for unload, for save. I don't know why I keep saying unload. If it is valid, we are going to get our data asset and we are going to load it. Now this time we have to use load asset blocking. So the reason we have to use this one is because we can't use asynchronous functions or timers or delays in, timelines or delays inside of functions. So it's the same logic here. We have to use the load asset blocking. But as I said before, it's not loading anything too heavy, so it should be just fine. So here we're going to cast to DA blueprint, not that, DA blueprint, and we're going to take this information and we're going to get what we need. So we're going to right here load. So we're going to get our snap points, and we can, or what we are going to do is we're going to set our filter here immediately. But we also need to make sure that we go through this and actually set our values here. So to do that, we actually need to delete it first, because in the event that there's more, we need to clear it. So clear. And then with this, we'll just detach that and get another reference because it has been saved. We're going to say set array element as well. Index goes in there, size to fit there as well. And array elements, we want to actually break it, like this. And we can connect the item in just like that. And if you select your break, you can say hide unconnected, so it's a bit easier to see. There we go. So this will create our set array elements. Our snap points will be added. The only thing we're missing now is we need to save our static mesh. So from here, we're going to get static mesh, and we're going to have to do the same trick. Load blocking, I'm just going to put it on completed. It's a bit of spaghetti, but it's not that bad. Just move this here. Actually, double clicked and open the C#. So this will be cast to static mesh. And with this, we will then get a reference to our static mesh and say set static mesh to our new mesh. Now, to see if this works, we already have an actor that has a data asset that has a static mesh. It may not have any of this, but it does have this, so we can test if that works. So if we go and select a data asset here, we say we want to use the floor, and we say load. and it changed our static mesh, we can actually see our static mesh now. That worked just fine. Now, if we cancel this and load, nothing will happen because it doesn't delete it, but that doesn't matter. It's not too important. So we'll leave it at this for now. We'll load again just to be sure it's all fine. And the next thing we need to do is our save. So for save, we're going to do pretty much the same thing. We need to make sure that this is loaded again. So we're going to say load asset blocking. Sorry, no, not yet. First, we need to make sure that we have a valid target again. So copy this, place it in here. There we go. And now we can actually load it properly because it's valid here. So we'll once again cast to our DA_blueprint. And this time we just want to say set our snap points to our snap point filter here. That is being updated on constructor, so we don't need to worry about it not being equal to that. It is at all times. And the next one we need is we want to call our static mesh, sorry. So here set static mesh. And even though this is a soft reference, it's pretty easy to fix. We just want to get our static mesh here, get the static mesh from it. So it may sound a bit weird. Static mesh get, because the static mesh that we want is actually the static mesh appearance, not the static mesh component or actor. So if we plug this in here, it will turn it from a hard reference to a soft reference, and that will work for us. So just like this. Now, one thing to note about this is we need to, if we want to change our static mesh here, we need to actually go into here and select it. So we need to go into actual details and get the specific components and then change the appearance. Now that we have our saving and loading, let's make it so that we can actually, well, let's test it first. Right here, what we want to do is we're going to add our 4 points, and we're going to set them up as they should be at the end. We're going to make one right here, and we're going to want to move it, so make sure you select it, otherwise it will move the whole actor. And if we look closely, we can actually see, I believe, the arrow, which is its direction. And you can obviously see when you're moving it that the thing is local. At least if we rotate, we can see the lines properly. It's been annoying that it's not more visible than that, but so we want to make sure that our red is pointing out. So our X is pointing out and our Y is pointing to the side along the actual mesh itself. Now we're going to add a second one. It's going to do the same thing on the other side. So we're going to rotate it 180 degrees and move it all the way to the end. So just check. Normally the values should be 250 because that's how big it is. It's 500 by 500. We're going to add another one right here. And this is going to be the same thing. We're going to rotate it here and move it all the way to the edge. And I believe that is correct. Yep, it's right on the edge. And the final one that we're going to put on the other side. So 90 or minus 90, sorry. And it is right on the edge. So now if we do save data assets right there, it has been saved. And if we open our floor, we can see that we do have our 4 snap points with the information that we passed through. The next thing we need to do is we need to make it so that we can actually see these points within the level. So let's try let's not try, let's succeed in setting that up with a few, well, it won't take that long to do that. It's rather simple. After we've done all of this, and normally we assume everything works, so we don't do any kind of extra stuff here. We're just going to go through this, and we're going to do a for each loop right here with our snap point filter. And we're going to go through and say break, because we need to know right here what snap point is. Yeah, sorry, actually, we'll just do it this way. It's not a problem. So what we're going to do is want to say add components. And we're going to go all the way to the bottom. We're going to get the add component by class. And the class we're looking for is SMC Snap. And the relative transform is our array element snap point, because that's the relative transform that we've just set up. So we want to actually save the snap points as well as a variable. So we're going to save them by doing promote to variable. And we're going to call this snap point comps. And delete it, right click it here in the bottom left to turn it into an array. And we're going to then add it instead of just setting, so we have multiple references. So So I'm just going to add a few reroutes. There we go. The next thing we need to do is we need to make sure that it is attached to the static mesh component. So reroute here and say attach to components. So attach component to component. And plug this in here. And the parent is going to be our static mesh. So drag that in, control, and let go. And the final thing we want to do is by default, we want to say set hidden in game. So set hidden in game. And the reason for this is because we don't want to always show these snap points. We only want to show them when we are trying to snap to them. So that will be with our shift click that we set up right at the beginning. So now with this, I need this to be true. Well, actually, we'll leave it false for now so we can test. If we spawn in our actor number 1, or it's already here, it'll make its 4 different points here. So if we do the same thing with our 1, it did not display them. Ah, yeah, sorry, my bad. So we're actually going to delete all this for now. This probably isn't the best thing to do. This would be the best method to use, but we're going to use our load data asset because we already have a function for that, and we'll just plug it in here because the reason that didn't work is because it never loaded these. So we're just going to tell it to load them here anyway. Yeah, we'll just do that. So normally now, if we do the same thing, it should work just fine. Press 1. Yep, there we go. We have the same points. They're appearing with no issue. The reason that one was working is because it already has them in here. So if we delete it, there we go. The next step is actually making these items appear when we press shift, because right now that's not what happens. So we want to say new hidden to true now because we want it to be hidden when we spawn. So if we press 1 here, they're not visible. Exactly what we want. The next step is in our AC tool now, we're going to have to do some extra stuff. So we're going to say IA snap and check if this is true. So we're going to make a new variable, once again from the action value here. Promoter variable is snapping, we'll call it. There we go. And detach that. On started, it becomes true. On cancelled or on completed, it becomes false. And let's just print to be sure that it is working. And we'll say 1 shift. It is indeed getting called once we press. And one extra thing I believe I forgot in the past, in the other part, is right here when we set the grid to true, what we can do to make things a bit tidier is we can, not tidier so to speak, to make it so that the rotation actually becomes kind of aligned with the grid. We'll get this and check if it's valid. If it is, we're going to get actor rotation. And we are going to split this and say set actor rotation. And it's going to be using obviously the same reference right here. So just put a reroute so it's nicely organized. Split our new rotation. Plug the X and the Y in, no problem there. But we're going to snap this one, this float, to 90 degrees. So that way it's set as close as it is to the previous rotation, but snap to the grid. So if we try that now, if we look kind of in a non-straight direction, I guess you could say, and we press 1, it's not rotated correctly. If we press Control though, it now goes to the 90 degrees. Now, if we rotate it, nothing is visible because it's a square, but it is rotating correctly as it should. It's just that it's not visible because of the actual grid utilization. So there we go. So that will now make it a bit smoother when going to the grid. Now, the next thing is our actual snapping. What we need to do is we need to know which elements can be snapped to. And to know that, we need to look around and see which ones are close enough to be necessary to display their snapping points. If it's miles away, we don't want to do a get all actors of class because that would take loads of resources for absolutely nothing because the player would never be able to attach it because he only has a range of 1,000. So what we're going to do is on triggered, we're going to make a function for that. So we're going to add a reroute, select that reroute, right click and collapse the function. And this will be called display snap points. Now I believe we're going to have to make some functions in here just to do it because there's a for each loop here, so it's just easier. But we're going to go through here first and we're going to check if we have a valid item. So let me just move that up. And what we're going to do is multi-sphere trace by channel. And it's going to be very, very simple. We're going to get our manager, or our player camera manager, sorry. And we're going to get actor location. And this will very simply do, if ever we are holding our key down, we will look around to see if we hit something. So I'm just going to show you with 4:1 frame here. If I do shift, I believe it was shift. It should be this. Oh, sorry, we didn't put a radius. We want a radius of our range, because I forgot that we made that variable. Just plug in the range. And now if we hold shift, we should see a kind of line for any object that was hit. And it's hidden right under us because that's the closest point. So there we go. So this works. Now what we want to do with this is we want to save the items that are hit. And we're going to be using a set for this. And I'll get into why a set over an array, because usually we use arrays. So let's just get this first. We will break this and we're going to check for A builds. So we're going to cast A builds right here. There we go. And we're going to promote this to a variable, or a local variable, sorry. And we'll call this L for local hit builds. And this is going to be a set. So in the right here, turn it into a set, and we'll simply say add the item to that set right here. And the reason we're using a set is because, one, it avoids us having to call add unique. And because we don't care about the order the items are being added, we just want to know that they exist. We don't need to have an array which sorts them. We just need a set so that we can handle information quicker. We're going to start by checking. Sorry, I'm actually going to have to make a new version of this. So I'm going to promote this, sorry, here to a normal variable. And this one is going to be called builds in range. It's going to be used to detect whether an item is close or not. So it's going to be added with this, and we're going to go through that in a second. So if this is empty, we need to actually handle it differently first, because if it's the first item or the first time an item is hit, we need to treat it slightly differently than what we're going to do after. So if this is true, that we're hitting a new item for the first time, we're going to get our hit builds here, and we're going to set our builds in range to that, very simply. And then we're going to tell it to turn this into an array, because by default you can't loop through an actual set, I don't think. Yeah, it will automatically call the array. So just plug this in like this, and here make a function. So in our A builds, we're going to make a function called show snap, and this is very simple. For each loop through our snap comms, and it's going to make them visible. So right here, sorry, set hidden in game to false. Then we're going to duplicate it with Control D, and we'll say hide snap. And this is going to be set to true. And so right here, these are being added because these have been hit right here. We're going to add them and say show snap right there. And so once the items are found, they get added to the array or to the set, and they get then revealed, so to speak. Now, on the other hand, if this isn't true, so it's not empty, we need to do this slightly differently, because we don't want to call, because it's getting called every frame we hold our shift down, we don't want it every frame to be adding or making them visible again, because that's a waste. It's not necessary. So the way we want to check for that is we're going to get our two sets here, and with the one on top being build in range, so make sure this is the top one, we're going to get the difference. And what the difference does here, you can read in detail if you want, but just to pretty much summarize what we're going to do, we're going to get all the elements that previously existed in the array or in the set, but that are no longer getting hit here. So whatever is in here, but not here, meaning any elements that are no longer hit, need to be hidden because they're no longer valid. Now, you could do this with a timer, which is how I originally did it, but this is a bit more, I guess you could say, optimal. I'm not sure if that's the case, but it feels better to do. So here we're going to say for each loop, sorry, we're going to call for each loop with an F here, and we're going to drag this in, and it will turn it into an array. And we're just going to say hide snap, because all these elements here have now been removed. So pretty much this contains elements X, Y, and Z, so to speak. And this one contains only element X because there is only the element or the building X that still exists. So that means that Y and Z are the difference, and they are the ones that will remain here and will be hidden because they're no longer valid anymore. So the next thing we need to do is check which elements were previously not hit but now are, so that we can tell them to be visible like here. So we're just going to copy this for now, and we're going to do the same thing as this, but the difference is we're going to invert the two. And what this one does is, as I just said, it does the reverse. It will get any elements that weren't previously hit and that now just were, and it will tell them to be visible. So this shows, this hides, and now we just need to save the new value with our hit built. So to showcase this working, let's just go and place an item or two like that, and we'll put one here. And now if we press shift, as you can see, the points appear. Now if we move out, they both disappear. If we go here, that one appears here, but it's not getting called all the time. They're only displaying themselves when they need to. Now the line trace is still happening because we can't really do without that. So, but this is kind of a better way to do it. Now the only difference is it immediately pulls it out, but what you could do is add a timer in the hide snap, but we're not going to be doing that here. Now currently, if we really release it, it doesn't actually do anything, and the reason for that is because, well, we haven't informed it that on release of our snap tool here that we want to clear them out. So that's what we're going to do very quickly right now. We'll get our builds in range. We will say to array, and this right here will get us our array to go through and just simply say hide, because we don't want to see them anymore because they don't theoretically exist anymore. Now the next thing here is we're going to say clear, because now we don't see any of them, so we don't keep running any logic, or we always restart from this point here. So back here, now the last thing we need to check, I believe, is if we have a build ref, because by default this shouldn't hit the build ref. If we run a test here, let's try. If we place one and we do shift, it appears. If we let go, it disappears. But if I try and place this, we don't actually see those points on our object that we're moving, and that's because we told it not to do any collisions. So to fix that, we're simply going to check if it is valid when we start pressing, and if it is, we're just going to say hide snap. And on release, we do the same thing, I believe, because right now if we press shift, it is not displaying them. Oh, sorry, that's my mistake. Show snap. It's obviously not going to show them if we're telling it to hide them. So let's try again, and they are visible now. But we also need to tell them to be hidden if we release. So hide snap right here. Now this will do it for all the appearance side. Next, we need to do the actual movement. So let's get into that. So the movement is obviously going to be in the update build location. We are going to drag all this to the side, or this little bit here compared to what we're going to do right now. I'm going to add a branch and on true. So if not, using the snap here, so not Boolean, plug it in here. And that means that as long as we are holding our shift, we will try and actually do another system, because obviously this is a bit too simple for snapping an item. So the first thing we do, just like here, we need to get our line trace. So I'm going to give us a bit of extra space by moving down here, because we will need it. So the first thing we want is we're going to get our impact point, and we're going to subtract the normal from it. So what this does is it will give us a slight offset for where we hit to be more towards the inside, because we're going to be using that to determine which is the closest snap point we can actually use. So this is going to be saved just to make it more readable. We don't have to save it, but we're going to save it as a local variable, which we'll call LImpactPoint. This will go in right there. And the next thing we need to check is we need to check if we hit a valid actor. Did we hit a build? So cast to a builds. Plug that here, and the same thing, just reroute this to make it a bit nicer. Here we go. Now, if this is false, so we didn't hit something, we want to say set actor location of our build reference right here to our impact point. And so right now, if we run this, even if we hold shift, but we don't hit anything, we can still move the item. And if we do grid, it doesn't work because it doesn't go through that logic, because it checks the snap. So it uses the rotation, it resets because that's handled separately, but it's not snapping. If we let go of shift, it snaps again. If we hold shift again, it's freely moving until we hit another actor of type A builds. So back in here, this is where we're going to be doing most of our work. So I'm going to save this A build as the hit actor as well. So we call this L hit actor. And the next step is we're going to need to make a custom function inside of our actor to check which is the closest transform available, because we want to check which one we can find closest to where we are using our impact point. So to do that, let's go into our A builds, create a new function, which we'll call get closest transform, and it's going to return transform here. So this is return value, and in input we need to know where we hit. So we want vector impact point, and let's just detach this for now and let's go through this. So this is going to be pretty much like any kind of thing where you're trying to judge the distance. So the first thing we need to do is we need to convert this to local space, because all our variables in our snap point are in local space. So inverse transform location, and the transform is going to be get actor transform right here. And we'll just save this as another variable, which we'll be calling L testing location. Plug this into the execution node, and we can start with a for each loop through our snap point filter. So split this so that we just handle this for now. And all we need to do is we need to break this and check if the location between this, so our distance between our vector here, our location of our snap point, and our testing location, which one is the shortest. That's what we're looking for. So to do this, we need to check if this is inferior to a variable that we're going to make right here, which is going to be called L distance. Now, by default, we need to make sure this is a value that is very, very high. So I'm just going to put, I think that's 1 million. I think that'll do. Anything kind of longer than 1,000 should be enough, because it never really is bigger than that. So then we put a branch. And so if this is true, that means that the distance is longer. And if the distance is longer, we need to update the new distance. So set L distance right here on true. And we'll also reroute the transform, and we'll be saving this as the return value. So we'll save this as a local variable. We'll call return transform. Just like that. The last thing we need to do is on our return here, we're going to say return node. And I don't think we need this one anymore, so we made a new one. We're going to split this, and we're going to turn this return from local back into world space. So with our transform here, so get actor transform, we'll say transform location right here. And this will say from local to world. So this goes here. And then we'll call the same thing transform rotation, taking the rotation and plug this in here. Now, by default, the scale shouldn't matter too much. We'll just plug it in. It usually stays 1-to-1. Nothing to really touch there, to be honest. Now, this needs to be pure, or it's better pure. It doesn't have to be, but we'll put it as pure. And in AC tools, we can now call from here our get closest transform. And so it takes in our impact point, and the return value, we're going to be saving it as what we'll call our snap point. So our L snap point, and plug this in right here. And there we go. Now, just to give you an idea how this works, let's make a debug sphere here so we can see how it's appearing. Now, this is going to be called, if I just break this, sorry, plug this in here, and let's put something like 50. We'll make it bright red so that we can actually see, and we'll make it last for 1/60th of a second. so that because it's being called every frame, it won't be like causing lag. So thickness of 1 will do. And so if we play this right now, if we place 1, this is just going to appear nothing's the problem. Now if we press shift, it's actually going to start showing which point is closest relative to where we're looking. Now here, if we look at the edge, it's about there. But if we start moving here, it appears at the new attach point down there. And the same is true on the side and here. Now that little red dot you're seeing is not from what we're looking at, but it's from our sphere. We don't need that anymore, but we'll remove it in a second. So depending on where we look, it'll actually select which attach point is closest. And we're going to use that to attach our new build towards that location. Now, to avoid applying any of this logic too often, we're going to use some tricks to kind of keep it lighter so that it only performs the moving once, unless we change the conditions, in which case it will move again. So we won't really be able to show. I'll try and show it with some like attach point with some spheres to kind of give you an idea of what it's doing. So we're going to make a branch here, and what we want to check for is we're going to check if our snap point here, if we break its transform, so right this, if it is different from the current building, so this one, if we get its snap point in world space, then the one that it's using right now, is it the same? If it's different, then we need to move it. That means something has changed. And in this case, it would mean that we are no longer trying to attach it here, but we're attaching it somewhere else. So from here, what we want to do is we want to get our SnapPoints filter, and we're going to drag this here and say get a copy, and use 0. And then we're going to right-click, split, right-click, split again, because we want to get our location. And right here from our building reference, we'll say get actor transform. And plug this in here by saying transform location. Basic one, plug this in here, plug this in here. And now by default, this isn't going to work, or at least it's going to keep calling itself because we haven't finished the positioning of the actor just yet. So if this is true, that means that we have changed where we are trying to attach it. Now, what we need to do here is solution to this, the solution to how we set this all up is we're going to start by changing the rotation. Because of how we've set this up, and this normally should work for any item you use no matter where the pivot is, we're going to rotate it first, and then we're going to get the difference between the location we're aiming for and the location we're currently at, and we'll then make that difference and apply it to the actor so that it moves after the rotation. The reason we have to do the rotation first is because our pivot point is not, or in most cases, or in our cases, or in our case, the pivot point and the actual attach point or snap point are not the same. So we can't afford to rotate after. So with our, not hit actor, but our building reference, we're going to say set actor rotation right here. And we will then say to get our make, I believe. So we're going to get this again. So from right here. And we are going to transform this time. Instead of here, we're going to transform it by our snap point because we want to do it relative to where we're going to attach it. We're going to transform rotation. And here we need to do a bit of extra because the default orientation that we have is pointed outwards. It's pointing towards the outside and we need to rotate it inwards. So we need to actually invert this. But the thing is, if we use the invert function here, this doesn't work because sometimes the rotation is 180 and it will just tell it to minus 180, which is exactly the same thing. So instead, what we do is we're going to convert this to a vector. So get forward vector of the rotation. And we're going to use this and multiply it by -1 because the vector being -1 will be 180. So if we turn it to a float, and do -1, make rotator from X. And the reason we use X is because we used forward, and that's the same axis. And then we plug this into our new rotation. So just like this. It's a bit messy and a bit long, so I'm just kind of aligning it as best I can. And so the last thing we need to do is here we're going to say set building location. So set actor. Oh, sorry. We're not setting its location. We are setting its offset. So set actor offset. And because the reason we're doing this in world is because it's much easier to do than doing all the conversions, and it's also why we're doing the offset instead of just saying set location, is because it's a lot easier to do the math. And that's also the same reason we need to do this only once, because if this gets called every frame, then this will move very, very fast, and we don't want that. So once again, copy this, plug this in here, and we want to use, we'll just remove this for now, and we're just going to copy this one because we need to use the transform, and we want to use our snap point, and we're going to split it, and we're going to say minus this one. So pretty much the goal we're aiming for minus the current location will give us the offset we need to have to move. Now, normally if this goes well, it will move it exactly as we need when we try and snap. So right here, if we press Control, we just lock it in so we can test it easily. Now, there's no snap points initially, but if we add a second one and we do Shift, they appear. And if we look at this, it will snap right to the edge. If we look to this one, the same thing here as well, and here as well. And we can place it and do the same thing on the next one as well. Now, obviously, if we look at this pivot, it's in the middle, so it's going to try and look on the other side. But if we look on the edges, it will work without a problem. And obviously, you can't build it there because, well, you're looking at a target that's already placed. And so we can build it just like that. Now, one thing to note about what we've done here is that you probably noticed that we're always using 0. Now, that's because in the next part, we're going to make it so that we can change that value. But I didn't want to make this one be too long, because otherwise we would end up being here for probably over, I'd say, an hour and a half, maybe 2. So I wanted to keep this separate as a third part for the last one, which will handle filtering as well as changing which snap point you want to use. Now, this sometimes looks a bit odd, but that's because you're changing snap points and not all snap points will work with each position. That's why we did the check for the can build at this location. So there's one last thing we need to do here. We just want to make sure that we say hit actor false here. But other than that, I believe that covers everything. Once again, thank you for watching. I hope you enjoyed the tutorial. It was a bit long, but I hope it's working all on your ends. In the next part, we'll be going over changing the snap point, as well as being able to freeze the item in place and make it so that some snap points can't actually accept some items. So if, for instance, you don't want the staircase to go to a certain location, you can do that as well. So I will see you in the next video. Goodbye.